All right, so this video is to answer a question about these three things, okay? So I got this in my email. So what we have here is f of x, f of 1, and the limit as f approaches 1 of f of x. And the question is, what's the difference between these things, okay? So before we look at how these things are related, let's look at them individually, all right? Let's start with x, if you have a nice highlighter. So x. So x was on a line, okay? So we have this line, okay? And x is on this line. So it's like a train, all right? It's stuck basically, on the track, and it can have values in here. If this line, if we're going to include all the real numbers on this line, okay? So, x can be here, right? In which case its value might be, 1.5. X can be here, right? In which case its value might be 3. X could be over here, right? Its value could be negative 2.91, okay? Something like that, right? But x can take on these values, okay? So that's x. X is pretty straightforward. Let's look at f without the x. So f is some kind of a function. Okay, now in our case it's a continuous function. It just means it doesn't have any breaks in it, okay? And f has a lot more freedom than x, okay? In this case, we're using a two-dimensional surface to represent x, and we're just saying that, okay, so x is this, f is just this curve, okay, or, squiggle, and think of it like that, right? So this is f. This is x. Now, so then we have this f of x. So what does that mean? Well, what that means is that we can write f and x okay, in a way that shows that they have a relationship. So in other words, f doesn't just do whatever it wants. F is dependent on x. So if x is 0, then f of x is always going to be right here, okay? And it's going to be doing this. It's going to be kind of like curving and going down, okay? If x is 4, remember, x is stuck down here, right? X is stuck on its line, so this is its line, okay? If x is 4, then f is always going to be right here, okay? So there it's, it's got some value, right? And it's going up, kind of heading for this curve. So as x moves along here, let's just say it's moving from left to right, okay? So as x moves along here, f of x, kind of like watching it, okay? Watching what x is doing. And as x goes along, f does its thing, but they're locked together. Okay, so f is dependent on x. So that's why we call this f of x. Okay? So we have x, we have f of x, and then we have f of 1. So what that means is that let's say that right here, x is equal to 1. Okay? And the question is, what is f doing when x is equal to 1? And there it is right there, right? So we can say that, we can't really say f of x equals because f of x is this whole thing, okay? But we can say f of 1 equals, and then we can come up here, we can look at this value, and let's just say it's, I don't know, it's 7, okay? So we can say f of 1 is 7. So at that height, when x is 1, f is at 7. And you can see that it's kind of going down, and it's heading for this trough down here. That's how x and f of x are related. So what's up with this limit as x approaches 1 of f of x? Well, notice that here we have an arrow, okay? And we call this approaches, right? This is as x approaches 1. Okay, that's how we read that. I think it approaches 2 p's. Anyway, so there's a couple of interesting things about this. Number one is that notice that x is moving, right? It's approaching something, okay? So if I ask you what's the value of x, well, you can't really answer that because it's a moving target. Yes, it's constantly moving. The question that I can answer, interestingly enough, is what is x not equal to, right? Well, if x is approaching 1, I don't really know what it's equal to, but I know for sure that it's not 1 because it's approaching 1, right? So x is definitely not equal to 1. So when we have this arrow here and we say x is approaching 1, right? We know that x is definitely not equal to 1, okay? X is not equal to 1. It's approaching 1. It's a moving target. And so the question is, okay, so since x and f of x are kind of locked together, f of x always is doing the same thing in relationship to x as x goes along, then f of x is approaching what? So the question is, if x is approaching 1, then f of x is approaching what? That's what this means. The limit as x approaches 1 of f of x, right? So what's f of x then? So as x approaches 1, so x is not equal to 1 anymore, okay? So here's 1, and here's x, and x is heading toward 1. Notice that x could head towards 1 from the left. X could also be over here to the right, and it could be heading towards 1. We don't know where x is. We just know that it's heading towards 1, and so obviously it's not 1, right? X is heading towards 1. So the question is, what's f of x doing? Well, f of x is heading towards 7, right? So no matter whether you're coming at it from the left or you're coming at it from the right, f of x is heading towards 7. So the limit as x approaches 1 of f of x is 7 in this case, okay? Now, if you have something weird, right? Like if you have a function that does this kind of thing, boom, and then suddenly it jumps over here and takes off, and maybe has a gap in it, all kinds of crazy stuff, okay? Then, and if this is f of x, and we've got x down here, then notice that, like, at this point, let's say this is 3, so the limit as x approaches 3 of f of x, okay, I don't know, let's say this is 5. This is going to be 5, because notice that as x approaches 3, from the left or from the right, x is heading towards 3, f of x is heading towards 5 in either direction. Yeah, its value is heading toward 5. But let's say that this is 6, okay? So now, as x approaches 6 from the left, f of x is heading up here, okay? And as x approaches 6 from the right, f of x is heading over here. So it's heading to two different things, okay? This is a really weird situation, okay? So this limit is not going to exist, okay? So the limit as x approaches 6 of f of x, does not exist, okay? Because, there's no f of x isn't going anyplace, right? I mean, it's going here as you approach from the left, it's going here as you approach from the right. Obviously, if f of x is not defined, if there's some kind of a big gap in f of x, and then you have some sort of a c in here, then as x approaches this c, f of x doesn't exist, the limit's not going to exist. So that's the difference between f of x, f of 1, and the limit as x approaches 1. Do you have any further questions about this? This is a very fundamental question to calculus. Okay? If you have any further questions about this, send me an email.